But, you know, if you make a 58, that means I guess I made a 58. So, really, it's all on me. Oh! That's not good. I'm videoing. Okay, so, hey, okay. Evens or odds? What do you care? What do you want to do? You are odd people, too. All right. Name the polynomial by degree and number of terms. Degree, hey! Degree. 4, which means what? Quartic. And then number of terms? So we say quartic polynomial with 4 terms. What if there were 2 terms? Binomial, 3 terms? 1 term? Okay. Write a polynomial function of least degree with the integral coefficients that has the given zeros. What do you write? X what? Plus 5, minus 2, and x minus 4. Good. Then what do? Well, alright. I'm going to go ahead and work the second and third one. So I've got x squared minus 4x minus 2x is what? Minus 6x. So minus 6x. And then what? Positive 8? All times x plus 5, yeah? What do you distribute first? X. So if I multiply everything by x, it just increases the power by 1. So x cubed minus 6x squared plus 8x. And then distribute the 5, yeah? So I'm going to distribute 5. I get what? What'd you get? 5x squared minus 30x, and then plus 40, combine like terms. So my final function is f of x equals x cubed, what? Minus x squared and there's my answer. Okay, let's do the next one. I got a negative 2i and a square root of 6. What does that mean? Right, so I have 4 zeros. Okay, so I should have x plus 2i and x minus 2i, x plus the square root of 6, and x minus the square root of 6. Okay, so we start fully? Okay, so I've got x squared minus 2ix plus 2ix does what? Cancel, so I've just got minus 4i squared, which is really what? Okay, so I'm going to mark that out and put plus 4. Okay, x times x is x squared, x times negative square root of 6, x times positive square root of 6, cancels out, and then what? Yeah, minus the square root of 6 times square root of 6 is just 6. So I've got x squared plus 4 times x squared minus 6, and we FOIL those, right? So x squared times x squared, x squared times negative 6, 4 times x squared, and then 4 times negative 6. Final answer? Oh yeah, I can add. There we go. We good? Okay, let's keep going. Factor. What do you want to do? How do you factor number 7? Take out an x? What are you left with? Okay. Does it factor more? Okay, so what do you call this when it factors x plus 4 and x minus 4? Difference of perfect squares. Okay. So x times x plus 4, x minus 4, and we're done. Yeah? What is x squared minus 15 factor to? Huh? Square root of 15. Right? So because the square root of 16 is 4, I can put a 4 there. If it's not a perfect square, then I got to put those there, right? What if it was x squared plus 6? Square root of 6i. And I know that because if I set that equal to 0 and solved, I would have to plus or minus the square root of negative 6. So I would write x plus the square root of 6i, x minus the square root of 6i. Okay. So are any of those fair game? Okay. Alright, let's move to number 9. Got a calculator? I'm gonna make my window the same window that's on the test, so for the review. I just sneezed into a video. Oh well. Okay. So this is my function. This is my graph, and it says sketch the graph of each function and approximate each real 0 to the nearest tenth. I don't do tenth. You know what I do, right? We do thousandth, right? Thousandth. And then approximate the relative maximum minima to the nearest thousandth. Okay, so I just need to, let's just find the 0 and the max and the min, yeah? So how do you find a 0? 0? To the left and to the right of it? Left, right, and there's my 0. Negative 0.804. Okay, negative 0.804, comma, 0. That's my 0, and then I'm going to write down my what, or find my what? Max and min. To be announced. To be announced. Okay, so I can calculate max, yeah? Or min. I don't care what you do first. Max to the left, to the right, press center, and I have a max at the point, negative 2 comma 6. And I have a min at the point, so basically negative 4. Negative 4 and 2. Okay, there we go. I'm good with that. What if I did ask you for increasing, decreasing? What do you use on increasing, decreasing, x or y? X? Okay. What's it doing first, increasing or decreasing? Okay, so I would say decreasing from negative infinity until the x value of this minimum. Negative 4? Okay, pick back up at negative 4, and I'm increasing until negative 2, and then pick back up at negative 2, and I'm decreasing until infinity. There you go. Okay. Solve using any method, find all roots, and write in factored form. What do you want to do? You want to factor it? You remember how to factor it? Yeah, group? You with me? Hello? Stop zoning. Okay. Are you writing these down, Sam? It's hard to when you're leaning so far away. And so, okay, I'm going to group the first two, group the last two, take the negative with the 4, yeah? What can I factor out of those two? What am I left with? What am I going to factor out here? Negative 4. So I'm left with a positive x, and then a what? minus 1, because a positive 4 divided by a negative 4 is a negative 1. So what do I write down? Okay. I want to solve. Have I solved yet? So when does this equal 0? When x equals 1. So when does this equal 0? And? Right, because this does factor. Now if you ever don't want to factor, you could just set it equal to 0 and solve. Yeah? Okay, there we go. Okay, so let's do number 13. Okay, how is this different? That's a power of 4 and that's a power of 2. Can I still factor it like a quadratic? Right. So I'm still looking for factors of 12 that add up to what? Negative 7. What do you think? Okay. So do I write x minus 3 and x minus 4? Good. Okay. So if x squared minus 3 is my factor, what's the solution? Could you factor that? There you go. X plus the square root of 3, x minus the square root of 3. Might as well, if I'm just solving though, yeah. This equals 0 when x equals plus or minus the square root of 3. And this is x equals plus or minus 2. So there's my 4 answers. Okay, let's do number 15. What do we do? Factor on x. What am I left with? Okay. Can I factor this further? How? Right, this is the same thing as saying, so I've already got x, and then I've got a cubed minus b cubed. Do you remember the formula? A minus b plus, right. If this is minus, this is minus, this is plus. You take away the cubes and then you say the first one squared, those two times each other, and then the last one squared. Yeah? So what's being cubed to give you 8? So I know my a and my b, yeah? So what goes here in this first one? A minus b? What's a and b? So x minus 2. Okay, what goes here? X squared plus 2x plus the last thing squared, 4. Okay. Well, let's see. If the distance from zeros, say final roots. Okay. Oh, shoot. What have we not been doing? Yeah. Well, why haven't you been reminding the rest of us? Yeah, I did kind of right here. X minus 2, x plus 2, and x minus 1, yeah? This one is x plus the square root of 3, x minus the square root of 3, and then x plus 2, x minus 2. Okay. And then this okay, so this one. Okay. As far as finding all the roots, real and imaginary, if I just said find where it crosses the x-axis, then you could say, well, when x equals 0 and when x cubed minus 8 equals 0, but if you set that equal to 0 and you added 8 to the other side, you could just take the cube root of 8 and get what? 2. Which means technically my graph only crosses the x-axis at 0 and 2, but there's 2 more imaginary solutions. As far as remembering that, that factoring, I'll probably write that on the board if you need it, okay? Okay, so I already know this. Can I factor that, or do I need to solve it? Are there factors of 4 that add up to 2? Okay, so I need to solve it, yeah? Quadratic formula, completing square? Okay. So none of you guys start the completing square on the test and then we don't get it. Okay, so what do I need to move? And make it what? Now what do? Divide this by 2. But what do I got to add to both sides? Not subtract. I got a lot of people subtracting to both sides. Because that's squared, right? So plus 1, which makes us what? So x plus 1 equals plus or minus the square root of, so 3i. And then how do I solve for x? When I subtract 1, where do I put it? Yeah? Okay. I'll do quadratic formula too. Oh, you're silly. I'm still going to do quadratic formula just in case anyone wants to. X equals opposite b, plus or minus the square root of b squared, minus 4 times a times c, all over 2a. What's 4 minus 4 times 4? Yeah, 4 minus 16 is negative 12, so I've got negative 2 plus or minus the square root of negative 12 over 2. What do you do? Factor out of, so I've got 4 times 3 and then times I, yeah? Square root of 4 is what? So negative 2 plus or minus 2 square root of 3i all over 2. What happens to the 2's? So negative 1 plus or minus the square root of 3i, we've got the same thing? Alright, so what's the factored form then? Yeah, we've already got x and x minus 2, right? Okay, good. Almost. X what? Right, if this is a minus 1, so it was opposite. So plus 1 plus the square root of 3i, and then x plus 1 nah. Okay. Okay, so there's that. Now what about this one? Okay, wait one sec. Let's go to, no, that's fine. Alright, let's do 17. How do you rewrite that in log form? Of is, okay. Put it in exponential. Right? This is the base, and they're never going to be beside each other, so if this is on the log side, then 2 is on the other side. Okay? What about this? To the is. Does that make sense? What is 1/2 power? Same thing as the square root, so it does make sense. Okay, so let's talk about 21. Anything that has a negative power should be put where? Well, first let's just go ahead and combine, and then we'll move them, okay? Okay, I've got a 3 times a 4 times a 1. What's 3 times 4? 12. I've got x to the negative 4th times x to the negative 4th times x to the negative 2. What do you do when you multiply variables? Huh? You add the exponents. What's negative 4 plus a negative 4? Negative 8 plus a negative 2? Negative 10, so I've got x to the negative 10, which I know I should write that where? In the bottom, so I'm going to go ahead and have my start on my final answer. I've got y to the negative 3 times y to the negative 2. Whoa. Y to the negative 5? You should be sorry. And so I put y to the 5th down here? Is that my final answer? Huh? Because it says your answer should only contain positive exponents. Anything that's... So like, if x to the negative 10 is in the numerator, put x to the positive 10 in the denominator. If x to the negative 10 is in the denominator, put x to the positive 10 in the numerator, so they switch. Okay. Alright, so what about this one? What do you do with that power of 4 on the outside? Okay. Do you want to go ahead and simplify the numerator before we do that? Okay, so that's just 1. That doesn't really matter then. So I've got 2 times 2, which is what? X to the 4th times x cubed, all over 2x squared, all to the 4th. Can we simplify this before we raise to the 4th? What's 4 divided by 2? What's x to the 7th divided by x to the 5th? X to the 2nd. X to the 5th. The other thing I just said. Right, because 2 of these x's cancel out with 2 of those x's, leaving me with just 5, yeah? So 2x to the 5th, all to the 4th. So now what do I do with the power of 4? Well, if you said 2x to the 20th, you would almost get it right. Well, you just distribute it as a power, right? 2 to the 4th times x to the 5th to the 4th. So 2 to the 4th is 16. And then x to the 20th, yeah. Okay. So what about 25? It'd be nice if they had the same what? Base? So 16 and 64 share what base? Or they're the same powers of what base? Right. 16 is 4 squared, 64 is 4 cubed, so I'm going to go ahead and say 4 squared to the x minus 1, and then 4 cubed to the 3x. So what can I do with the bases now? I don't know why I put that up there, you can't see it. Okay, so now I can cancel out the bases, because the only way they're going to equal is if their powers equal each other. So what am I left with? Minus 2 equals okay, what are you going to do? So negative 2 equals 7x. So what's x equal? No. Negative 2 7. Alright, negative 2 over 7. Divide both sides by 7. Can you have a negative answer when you have exponents? It's fine. Yeah, that's fine. The only time you have a negative answer is a problem is if when you plug it into a logarithm and you still have a log of a negative number. Okay, so now let's do 27. What do we do? What do you want to do? Right. Guys, hello. Alright. So, 3 times 4. What else? What else can you do with the numerator? Okay, so y to the 5th, because I got to add the powers. Can I do anything with that x squared yet? Okay. Okay, so just the x or the 2? The x to the negative 2 I can move, but the 2 I can't. The 2 doesn't have a negative power. So the 2 needs to stay down there. I agree that the x to the negative 2 can be moved to the top as x to the positive 2, y to the fourth, does it stay down here? Okay. Right, so what do you want to do? You said combine x squareds, what's that? So x to the fourth. Okay, so we combine those. What else can you do? 12 divided by 2 is what? 6. Right, just y. 4 of those cancel out with 4 of those, right? We good? 9 weeks test. Yeah. We'll do it tomorrow. Okay. No, I was just gonna post them on my YouTube channel. I found it. So, what I'll have if you want to, what I'll have you guys do is leave me a number. You wouldn't mind me texting you, so I can just text you the link, because not all of you on my celly, are you? Right. So a number to text is easy, right? And I'll just do that through my Google number, and I'll email you or text you the link, and then you can just go to the link on YouTube, and it'll have the video on there. Okay? All right. You'll also have the problems from yesterday if you want this. Okay, so this one says graph f of x and find and identify the domain and range. Then find the inverse g and graph the inverse and identify the domain and range of the inverse. Okay, that's missing a period. We should all put one there. Okay. So, what do you want to do first? Do you want to graph it? Identify domain and range? How do we graph this? With a calculator? Okay. So let's grab our calculator. Y equals 4 times 1.4 raised to the x. Okay, now I am going to look at the graph for a minute. Should we make our window the same they have? Okay. I'm only going to look at the window to actually get a look at it, but I'm not going to use the window to sketch my graph. What am I going to use to sketch my graph? No ideas? No? Well, I mean, I am gonna plug that in, but I'm not just gonna look at this and be like, oh, it looks something like this. How can I make sure that my graph is accurate? Go to the table. That's what I'm saying. Go to the table. Okay. So here's what I'm looking at. I'm looking at negative, the furthest I see to the left is negative 4, right? Negative 4 is 1.041, yeah? So at negative 4, I'm going to make this over here. Negative 1.401, or positive 1.401. So which is like right here, yeah? Huh? Huh? Oh. Oh, I see. Scale is 2. Okay, so it needs to be like right here. Okay. Just kidding. Thanks. And then so negative 3 is like right here. Yeah? Negative 2 is like right here. Negative 1 is like right there. Go to second table set and go to auto and press enter. Okay, at 0, what are we at? 4. What about at 1? So if this is 6 and this is 5, then this is 5.6 somewhere in here. What about 2? So close to 8. 3? 10.96, so almost 11. 9.76. 4? 15.36, so 5. 5 is what? 21.5? And is that as far as I can graph? Okay. Quick question. Where is the function going as you go to the left? what is the y value going to? 0? Is it ever going to hit it? No. Okay, so here's what I know my graph does. And this is a more accurate graph than just kind of like being, looks something like this. I actually plotted points, and there we go. Okay, so this is f. Okay. What's its domain then? Domain is x, yeah? So how far to the left it goes and how far to the right does it go? All real numbers? What about range? What's the lowest it goes? No, 0 with a parenthesis, right. It goes to 0, but it doesn't actually hit it. And then goes all the way up to what? Infinity. Do I already know my domain and range of G, which is f inverse? Don't I? 0 to infinity, and? So I don't even have to know the graph to know that these are just going to switch. Okay? How do I graph the inverse? I could graph the inverse without even finding the function yet. How? What switches when you do inverses? The x's and the y's. So why don't I go to my table and just read it backwards? Because even if I get my inverse function wrong, oh, I went the wrong way. Okay, so here's what I know. I know that at 1, I'm at -4. You with me? So we just read it backwards. If this is my x, then this is my y. So at 1, I'm at -4. Basically at 1, right? Okay. At point, so what am I getting closer to? I'm getting closer to this 0, right? Let's go ahead and say, we didn't write down, but this is a horizontal asymptote on that one, yeah? Horizontal asymptote at, what is that equation? X equals or y equals this horizontal one? Because it goes through the y-axis. So on the inverse, I'm going to have a what? A vertical asymptote at x equals 0. Good. Okay, so let's plot our points. Okay, so we already know that it's at 1.5, basically, I'm at what? -3? At 1.5, I'm at -3. At 2, I'm at what? -2? Okay. At 2, I'm at -2. At 2.85, I'm at what? -1? Yeah? At 4, I'm at what? 0. At 5.6, I'm at 1. At 7.84, I'm at 2. And at 10.96, I'm at 3. That's good enough, yeah? So here's what I've got. Now, it would be a mistake to keep your function going like this, right? Why would that be a mistake? Right, which is your vertical asymptote. So keep your vertical asymptote going, and then just sketch it going down like this, and then there you go. Huh? Uh-huh, and this is 4. Remember, it's going by 2. Okay, so does this fit with my domain being from 0 to infinity and my range being all real numbers? Does that fit? Domain? What's the farthest to the left it goes? 0. Which is why we said for the inverse domain is 0 to infinity. And then range would be from -infinity to up. Okay, what's the only thing we haven't done? Find the inverse. We didn't actually find the inverse. So if y equals, so let's write this down. Y equals 4 times 1.4 to the x How do you find the inverse? What do you do first? Okay, x equals 4 times 1.4 to the x. Oops, sorry, you're right, to the y. Now what do I do? I need to solve for y, right? What do you need to get rid of before you can get that out of the power? The 4. How do you get rid of the 4? Alright, so let's divide by 4. So x divided by 4 is 1.4 to the y. You have an exponential equals another expression. How could you put this? How could you get the exponent out? Log form? You want to throw a log in there, or you want to take the log form? Let's just put it in log form, right? Log base what? 1.4 is the base, right? Base of the exponent, base of the log. 1.4 of is, which is g. And there's my inverse. The original function. That's what we were finding the inverse of. Okay? Alright.